Anuradha madam.
Okay, sir. Good evening, everyone. It's my privilege to introduce our distinguished resource person for today's session, Dr. R. Karthikeyan, a multi-talented professional with a wealth of experience and accomplishments. Dr. R. Karthikeyan is a professor and head of Dr. NGP Institute of Technology, Coimbatore. Dr. R. Karthikeyan is a distinguished academician with over 2 decades of experience in teaching, research, and administration. He holds a PhD from Anna University, Chennai, specializing in hybrid meta-heuristic algorithms for improving diabetic retinopathy classification. His academic journey includes an MTech from Vellore Institute of Technology, Vellore, and BE from Tayargarh College of Engineering, Madurai. Dr. Karthikeyan has served in prominent roles, including as a professor at PSNA College of Engineering and Technology and as a resource person for numerous FDPs, workshops, and seminars. His contribution include research in artificial intelligence, machine learning, and IoT with publications in reputed journals like Springer and elsewhere. He is the recipient of Professor of the Year Award Engineering at the 3rd International Business and Academic Excellence Award 2021. Dr. Karthikeyan is also a member of Asia Society of Researchers and has mentored students for national level hackathons like Manthan 2021. Dr. Karthikeyan's extensive experience, innovative contributions, and dedication to education make him an exceptional guide for advancing knowledge in data science, artificial intelligence, and related fields. We are honored to have Dr. Karthikeyan here with us today. Please join me in giving a warm welcome to our distinguished guest. Thank you, sir.
Thank you, madam. Am I audible?
Yes, sir.
Thank you for your warm welcome. Thank you, Dr. Srinakesh, for giving this opportunity to act as a resource person in this ATAL FDP. Thank you, Dr. Srinakesh. So now I will share my...
You are at liberty and you can go ahead.
Okay, sure. Thank you, Nagesh. Thank you. So hope my screen is visible.
Yes, sir, visible.
Thank you. Very good evening, one and all present here in this online ATAL FDP. The topic allotted to me is traditional artificial intelligence versus generative artificial intelligence. Actually, for the past 10 years, we are all talking about artificial intelligence very much, but artificial intelligence is very conventional technology. We all know the foundation, that is the father of AI, John McCarthy. In the year 1956, he coined the term artificial intelligence. But anyway, recently we are all speaking about generative AI. We are all working with the tools like ChatGPT or Gemini, various AI tools. We are all using it. But anyway, as the academician, we should know the comparison between traditional AI versus generative AI. So you can just consider this presentation, which is going to explore the evolution of artificial intelligence, as well as what are the various capabilities and the limitations of traditional AI by comparing with generative AI. That is, even nowadays, some of the projects development is going on in industry as well as in academia by means of the traditional AI. But anyway, due to the emerging of generative AI, what kind of capabilities and what kind of limitations of traditional AI by comparing with the generative AI. So, anyway, if we are working with generative AI, we should know about the foundations of traditional AI, because as the academician, we have to transform the foundations also. We have to transform the foundations also. That is also very important. Then only our students may become more strong in their technical domain knowledge. So now you just consider artificial intelligence. We all know, which is going to mimic the human being. Which is going to mimic the human being. So when we are developing the artificial intelligence, there are 4 categories of artificial intelligence. We all know system, that is whatever the system we are going to develop, the system that think like a human being, the system that act like a human being, the system that think rational, the system that act rational. So when we are developing the AI system, we have to be focusing on the human behavior as well as rationality. So this is very important thing. Okay, fine. Now we have developed one AI system. How we are going to test the AI system in the initial stage? I'm talking about traditional AI. So when we are talking about traditional AI system, we are all very much familiar about the Turing test. The Turing test, in the sense, the test which is going to examine the artificial intelligence system, whether it is 100% AI or not. So we are aware of the Turing test. The Turing test, which is going to examine the system, how the responses are given from the system. If the third parties are getting the response from that particular system, the third parties cannot be able to differentiate whether the response is coming from human or the response is coming from the machine. If the third parties cannot be able to distinguish between the human and AI, then the AI system is 100% pass in the Turing test. This is actually our traditional AI. So we are aware, we should be aware of this particular traditional AI. So now in this particular presentation, I'm going to talk about what is traditional AI. In traditional AI, we are going to discuss about rule-based artificial intelligence and supervised learning. Then limitations of traditional AI. What kind of limitations are there in traditional AI? Then the rise of generative artificial intelligence. Then what is generative artificial intelligence? Key capabilities of generative artificial intelligence. Then what are the advantages and potential applications of generative AI? Then ethical considerations with generative AI. And finally, the future of artificial intelligence, that is how the integration of traditional and generative approaches. Because the future of artificial intelligence, definitely when we are integrating the traditional and generative approaches, there will be a better future of the artificial intelligence. So these are all the contents of the today's session. Now we can just consider the traditional AI. So we're all mainly, even though if we are dealing with most of the generative AI applications, but still if we are developing some traditional AI system, either we are going with rule-based system or we are going with supervised learning. So rule-based system, first this is actually pure traditional artificial intelligence. So this particular rule-based system, so for this, the rule base is very, very important. So rule base in the sense, a lot of conditions and actions. That is, normally the rules are in the form of if-then format. If-then format. For example, if today is Thursday, then tomorrow will be Friday. So like that, we have some basic rules in our day-to-day life. Maybe if you come across taking the subjects of artificial intelligence, if today is sunny, then there is no chance of rain. So like that, we have the various condition action rules. So the traditional AI is completely relying on predefined rules and algorithms. The first point is traditional AI relies on predefined rules and algorithms. So based on this predefined rules and algorithms, the data analysis is possible as well as the decision making is possible. So any artificial intelligence system, data analysis is very important as well as decision making is very important. Even with the traditional rule-based artificial intelligence, we can analyze the data and we can make the decision. The next one is the supervised learning. So this supervised learning, we are aware of various supervised learning techniques. This supervised learning is trained on the labeled data sets. What do you mean by the labeled data sets? If we are downloading some open source data sets, maybe sometime the data sets may not have the label, but the supervised learning is trained on labeled data sets. For example, we are giving some caption for the particular attributes. We are going to give the caption for the particular attributes. So it is trained on labeled data sets. From that labeled data sets, the patterns can be recognized. And based on the pattern, the prediction can be made. Based on the patterns, the prediction can be made. Okay. So this is actually the concept of the supervised learning. So now you compare with this two technique. The two technique is ultimately different, rule-based system and supervised learning. So rule-based system, there is no data set is needed. Only by means of some predefined algorithms, we can analyze the data, we can make the decision. But in supervised learning, it is trained on the labeled data sets. From the labeled data sets, the patterns can be recognized, and from the patterns, the prediction can be made. So this is the two different systems in your traditional AI. Now let us consider the first, the rule-based AI. So first, the rule are typically expressed in the form of a logical format defining the conditions and actions. So if this is the condition, then this should be the action. Like that, everything can be defined in the form of a rule. So the rule base is very important for this rule-based artificial intelligence. For an example, if you consider the medical prediction, suppose you just consider if the doctor is asking like what are the symptoms of the fever, or what are the symptoms of the headache, what are the symptoms of some other diseases. Okay, so for that, if this is the condition, then this should be a disease. Like that, for every disease, the AI is maintaining the rule base. The rule base is very important for the traditional AI, that is rule-based artificial intelligence. One of the best example is for the medical system. In the traditional AI trend, everything can be inferred from the rule base. So rule base in the sense, the collection of various rule. Every rule is in the form of a logical format, which is going to define the condition and action. Okay. So now you can just consider the key concept of this particular rule-based AI is whatever the AI system in the rule-based AI uses these rules which are available in your rule base. The rules can be used predominantly by the AI system. By using the rule, the input data can be analyzed. Input data, if you are giving any new symptom, if you are giving any new value, a new data. So maybe you are all aware of training and testing. Okay, training data and testing data. Already the rule base is trained. Now, if we are giving any new input data, if you are giving any new input data, based on the rules, the input data can be analyzed. Based on the rules, the input data can be analyzed, and how what are the conditions are matched, what are the conditions are matched, and then the corresponding actions will be executed based on the rule base or based on the logic. So here the first step in your rule based AI is the system is going to use the rule to analyze the input data, and second step is condition matching. Then the third one is the execution of action based on the established logic, So now you can just consider this key components of the rule based system. So for any rule based AI system, the three components are very important. One is the knowledge base, another one is the inference engine, the third one is the working memory. So you can just consider this knowledge base. So knowledge base consists of collection of rules which is going to be represent a expert knowledge about a specific domain. So whenever we are going to create a knowledge base, the domain knowledge is very important. So for construction of knowledge base, the domain knowledge is very important. So we have to be interact with any of the domain expert. As the AI developer, for what domain you are going to develop the rule-based system. For example, if you are going to develop the medical-based AI system, then definitely you have to identify the doctor as a domain expert. You go and interact with him. You share your problem statement. What rule-based system you are going to develop? You share your problem statement to the expert. Based on the expert knowledge, based on the expert opinion, you are going to create a various rules for your knowledge base. You have to create a various rules of the knowledge base. You are developing the rule. You are all engineers, or you are all developing the AI system. You are all writing the rules. Okay, but anyway, the rules are going to be validated by the domain expert. The rules are going to be validated by the domain expert. That is very, very important. Whenever you are going to create a knowledge base, you interact with the domain expert for the validity purpose. The second one is the inference engine. So what actually this particular component of the rule-based system, inference engine, will do is, which is used to draw some conclusions. So how it is possible? Here, the interpretation of rule. If new incoming data is coming, the incoming data is new. Okay, so this, based on this incoming data, the corresponding rule can be interpreted. Based on the rule as well as the incoming data, the conclusion is drawn. Okay, so this is a very important component of your rule-based system, that is inference engine. This is very important. And then the third one is the working memory. So when the rule-based system is working, whenever we are working with the rule-based system, so the working memory, which is very important, which is going to store the current facts and data, being processed during the rule execution. What are the current facts are coming? What are the current data are coming? Okay, so these facts and data which need some storage area. So for that, the working memory is needed. So rule-based system which is having some working memory. So there are three components of your rule-based system. One is the knowledge base, second one is the inference engine, the third one is the working memory. So this is the three important components of your rule-based system. Okay, so maybe we are all in the era of generative AI, but we are discussing about traditional AI. We are discussing about traditional AI just for comparison. But anyway, still the rule-based AI, which is having its own advantages. There are three advantages. One is the transparency, maintainability, and then explainability. So anyway, these three advantages, we are all should be aware of how the rule-based systems are more powerful. So now you can just consider the rules are explicitly defined in your rule-based AI. There is no any implicit, there is no any hidden of rule. The all 100% rules are explicitly defined. So based on the rules, you can understand the reasoning behind the system decision. If your AI system is making some decision, behind the system decision, what is the reasoning? We can, as the human user, we can understand the reasoning behind the system decisions. Why we can understand the reasoning behind the system decision is, in future, if we are going to develop the system, the same system, then this understanding the reasoning is very important, so that based on the rule, we can understand the reasoning behind the system decision properly, because the rules are transparent, the rules are explicitly defined, then second one is maintainability, because for any real-time system, the rules are huge. Large number of rules are available in your rule base, or some of the rules may become obsolete. Okay, so then and there, the rules can be modified. The modification of the rule as well as updation of the rule is very important, because if we are forming one particular rule base which cannot be suitable for every time, the rules can be easily modified or rules can be easily updated. This facility is available in your rule-based AI, that is in your rule base, so that the maintenance of the rule base, which is allowing us for the flexibility in the sense, at any time any rule can be modified, at any time any rule can be updated as the new information. So this is called maintainability. So this is the second advantage. One is the transparency, the second one is the maintainability, then the third one is the explainability. So explanation of the rule, that is the logic behind the decision, can be traced back to the specific rule, based on which rule the decision can be taken. So the backtracking is possible in your rule-based AI, so that the logic behind the decision can be traced back to the specific rules, so that the trust and confidence of the rule-based AI can be fostered. The trust and confidence of the rule-based AI, when the people are developing the rule-based AI, the trust and confidence can be very good. Okay, so this is the three advantages of your rule-based AI. Okay, fine. Now, from the rule-based AI, the people are switch over to the supervised learning. So in this supervised learning, I want to share two important key points. One is the guided learning, another one is the structured data. Guided learning and another one is the structured data. So you're all aware the supervised learning is a type of machine learning. So normally you can just consider the machine learning. There are three types of machine learning algorithms. One is the supervised learning, another one is the unsupervised learning, Then third one is the reinforcement learning. But out of this three, for traditional AI, we are mainly focusing on supervised learning. So why we are focusing this supervised learning more is, which is called as guided learning. So supervisor means some guide, they are providing some guidance. Okay, so here the AI model is going to learn from the label data. All the data are 100% labeled. All the data are 100% labeled. So from the labeled data, the AI model is going to be learned. So in your supervised learning, why it is called guided learning is, the AI model learns from labeled data. The AI model learns from labeled data, which means each example has a known output. Each example has a known output. That is, when you are working with the supervised machine learning, so first you have to train your system based on the training data set. So whenever you are working with any real-time data set from the repository like Kaggle or the UCI main repository, so the data set we have to take as a labeled data set. We have to take as a labeled data set. So for each and every labeled data set, we should have some input variable as well as some output variable. For any Kaggle, any Kaggle or UCI repository data set, some features are input features. Based on the input features, the output can be predicted. Okay. So each example, it has a known output. So this particular guided learning, which is going to make prediction for new or unseen data. This particular supervised or guided learning, which allows the model to make the prediction for new or unseen data. Here, the new or unseen data may be called as the test data. That is the test set. Suppose you just consider your training set and testing set. You take a whole data set, either 70% of the data set, first it can be considered as a training, then the remaining 30% can be considered as a testing. Then the other 30 will be considered as testing, the remaining 70 can be considered as training. Like that, you will take a different combinations of training and testing data. You are trained your system based on this particular training. The model which is going to make the prediction for any new unseen data. If any new input is coming, based on the new input, which is going to make the prediction. So prediction to be, practically we are speaking, achieving 100% may not be possible, but we have to aim for 100% depending on the data set, depending on the noise of the data set. Achieving of accuracy can be varied. Either you can achieve 90% or you can achieve 85%. So the prediction is very important for your supervised learning. So this guided learning will allows the model to make prediction for any new unseen data. Okay, fine. So now we can just consider the data. So this particular data for the supervised learning or the supervised machine learning, the data should be structured one. What do you mean by structured data? The structured data with all input features with corresponding labels. Okay. So you can just consider the labels, the target values, the machine learning model which is aims to predict. For an example, you can just consider if the age of a person is like this, occupation, suppose the age is 18 to 20. If the age in the range of between 18 to 20, the occupation of the person is student, then he is interested in purchasing some new model of phones, new model of laptops, Like that, you have one the data, okay, the data set. So this particular labels are the target values the model aims to predict. Here, what the machine learning model is aiming to predict is the prediction of purchasing of mobile phones, prediction of purchasing of recent mobile phones, or prediction of purchasing of recent the latest laptops. So like that, the target values the model aims to predict are nothing but the labels of the particular data set. So this particular supervised learning mechanism or guided learning mechanism is widely used in various industries. Some of the examples are your finance industry, your healthcare industry, e-commerce industry. In all these industries, the supervised learning can be applied. The supervised learning can be applied. So now here I wish to share some two types of some commercial types of supervised learning. Whenever we are doing some projects or whenever we are doing some conventional research work, we are all working with regression and classification. Okay, so you can just consider the regression. Regression is prediction of the continuous values. So normally you can just consider any data values. The continuous values are one of the type. The another type is categorical values. We will see in classification. So you can just see a regression. The data value should be a continuous values. Continuous value in the sense, for an example, you can see the slide, the price of a house or the price of the stock, which is actually the continuous value. Suppose you just see the stock market value, continuously the value is getting updated. Like that, you can just see the price of a house that is also continuously updated. Okay, so the value is getting updated frequently or continuously. Okay, so the regression supervised learning technique which is used to predict the continuous values, for example the house price prediction or the stock price prediction. You just consider the classification. So here we are focusing on the categorical values. You have data value which is not having any continuous values, which is having some category. For example, you can just consider the student in our college, whether he is a hostler or day scholar. So hostler are one of the category, day scholar is another category. Like that, you can just consider this particular slide, email. The email can be classified as spam email or not spam email. Spam email or not spam email. So like that, by means of the classification, the categorical values can be predicted. Categorical values can be predicted. Okay, so this is the two different types of supervised learning we are mainly focusing. Suppose now you can just compare with this regression and classification as of traditional AI. We are going to compare. So now you can see this particular comparison. The regression aims to find the relationship between the input features and continuous output values. So what are the input features in your data set? What is the continuous output value? Between these input features and continuous output value, what is the relationship? What is the relationship? So for finding such relationship, some algorithms can be used. The algorithms are either linear regression we can use or polynomial regression, that is non-linear regression we can use. So based on the linear or non-linear regression, we can implement this particular regression scheme, which is used to find the relationship between the input features as well as the continuous output values. So this is one of the regression technique of your supervised learning. Then the another type is classification. You can just see the classification, which is going to categorize the data into some predefined classes. Predefined classes. So predefined classes, as I have already told, your email is spam email or not spam email. Either students are hostless or day scholars. Whether the employees are salaried employees or contract based employees. Like that, we may have different categories. So the categories can be identified by means of the classification. So categorize the data into some predefined classes. So for this particular classification, we may have logistic regression, decision tree, or a support vector machine. Logistic regression or decision tree or a support vector machine can be used. So this is the comparison between the regression versus classification. Now you can just consider this regression model. So we are just considered the linear regression. Some important highlights of the linear regression. By comparing with non-linear regression, the linear regression is very simple model. So we all know the comparison between the linear relationship with a non-linear relationship. Normally linear relationship is going to be represented by a straight line. So you just see a linear relationship between a features and target variable. If you're taking a features and target variable, if you are drawing a graph or if you are drawing a plot, the plot will show a straight line. The plot will show the straight line, okay? Because the relationship between the features and target variables are non-linear, linear, okay? So this is the linear relationship in your linear regression. And then based on this particular relationship, the continuous values, predicting the continuous values, used to predict the continuous values is possible. Suppose, for example, if you put a plot based on the values of the plot, you can predict the continuous values. So this is the three important features of a linear regression. It is a simple model, linear relationship can be maintained, and continuous values can be predicted. Continuous values can be predicted. The next one is a logistic regression. Logistic regression. So you can just consider linear regression is for the regression scheme, but you consider the logistic regression, which is a binary classification. What do you mean by the binary classification? Just now we have discussed your emails are spam email or not spam email. Spam email or not spam. There are two classes. One is the spam, another one is the not spam. So the logistic regression which shows the binary classification. So here the logistic regression which uses the sigmoid function, which is not like a linear function, it's a non-linear function, sigmoid. So you can just consider this sigmoid function uses a sigmoid function to map the input values, to the probability between 0 and 1. So you have the input values can be mapped to the probability between 0 and 1. That is the representations of the likelihood of belonging into a specific class. For example, one input value is going to map to a probability 0.5 means then the particular input value belonging to the specific class is 50%. 0.5, the probability is 0.5, 50%. Like that, 0.25 is 25%, 0.3, 30%. So like that, a sigmoid function which is used to map the input values to the probability between 0 and 1. So this is the sigmoid function which can be used in a logistic regression. Then based on this binary classification, sigmoid function, the categories can be predicted. Used to classify by means of this logistic regression, the data can be classified into two or more categories. For an example, you can consider the binary classification, either a spam email or not spam email. Okay, but you just consider the medical diagnosis. You can just consider medical diagnosis. In medical diagnosis, always the binary classification may not be work out. always the binary classification may not be work out. So why I'm saying this is, suppose you just consider the medical diagnosis. So maybe while I'm talking about my this particular logistic regression, so definitely I have to take the concepts of my research work. In the research work, I have classified the diabetic retinopathy. I have classified diabetic retinopathy using supervised learning. Okay. So if you are feeding any one of the input, the retinal image, either the retinal image can be of different abnormality or normal. For an example, I have considered the various abnormal category, like for example, like the early stage of diabetic retinopathy, which is called microaneurysm, and the next one is the some middle stage, that is the neovascularization, and then hard exudates, soft exudates, or otherwise it is a normal retina. So here you can just see I have listed out 5 categories of the retinal image. 5 categories. What are the 5 categories? The microaneurysm, neovascularization, hard exudate, soft exudate, and then your normal retinal image. Like that, the logistic regression can be used to classify the data even more than 2 categories. Always the binary category, the binary classification may not be possible. Based on the applications, we can go with either binary or n-ary. N-ary in the sense more categories. Okay, so this is the examples of logistic regression which can be used in the classification. So now you can just consider the very famous classification algorithm, a decision tree algorithm. So this decision tree algorithm, like a tree-like structure. I'm not going to explain the algorithm of decision tree. I'm going to just give a decision tree like structure, which is going to organize the data into a tree like structure, where the tree structure, there are different nodes are there. Each and every nodes is going to be denote a decision based on the feature. Each and every node is denoting a decision, and the leaf nodes is called a prediction. Maybe the root nodes and intermediate nodes are the various decision. The leaf nodes of a particular decision tree, which is nothing but a prediction. Leaf nodes. Okay. So one of the very commercial example for this particular decision tree is maybe if you come across a problem called waiting for a restaurant, waiting for a table in a restaurant. So for that, you have the various decisions you are taking, based on the various decisions, the various prediction is possible. For example, if it is a weekday, you have to wait for a table. If it is a weekend, there is no chance to get a table, so you can go to some other restaurant. Like that, there are different kinds of prediction in your leaf nodes, so that the decision tree with each node, that is the root node and intermediate nodes, which is going to be denote a decision, each leaf nodes which is going to denote a prediction. But anyway, these decision trees are very easy to interpret, very clear and easy interpretable model, which shows the decision making process very easily, very clearly. The decision making can be shown, and what are the different factors that is going to influence the decision, we can exactly retrieve the various factors from this particular decision tree model. So and then maybe another famous one is the random forest. So here in the random forest, you have the ensemble learning and bagging technique. So ensemble learning is combining the multiple trees. So that the term is called the random forest. You just consider a forest, there are multiple trees are there. So combines the multiple decision tree. Why we are combining the multiple decision tree is the prediction accuracy can be improved, as well as the overfitting. Due to the noise, some overfitting occurs. The overfitting can be reduced. Overfitting can be reduced. Okay, so this is the ensemble learning. And then bagging technique. So bagging technique in the sense from the particular multiple decision tree, some different subsets of the data can be taken and train the multiple decision tree on the subsets. Whatever the subsets you are going to consider is like a bagging. Bagging is nothing but create a different subsets. So once you create a different subsets, then the multiple decision tree can be trained on the particular identified subsets. So this is called random forest. And maybe this is a very famous classification algorithm. This is called the support vector machine. So in my research work for the diabetic retinopathy classification, I have used some optimized support vector machine. So this particular support vector machine here, the hyperplane and the support vectors, these are all the two terms. You can see the particular graph, the hyperplane in a multi-dimensional space. So hyperplane in a multi-dimensional space, which is used to maximize the margin between the different classes. If you are having the different classes, multiple classes, the hyperplanes are going to maximize the margin between the different classes. It will create a clear separation, which will create a clear separation. So for that, the hyperplane separation is very much useful in your support vector machine. And then what is actually the support vector is the data points are closer to the hyperplane. The data points are very closer to the hyperplane are called support vectors. So this particular support vectors play a crucial role in determining the hyperplane's position. Whether the support vectors are in the either the category X or category Y. So based on the support vector value, we can determine. So like that, based on the support vector machine, we can classify the data. So these are all the various applications. I'll give you a pictorial representation. So you can just consider the medical diagnosis, then your stock price thing, then your automated parking, as well as you can just consider the e-commerce applications and your chatbots. You may use not exactly a chatbot, this is like a robot. Okay, so we may use the supervised learning. We may use the supervised learning. So what is actually the limitations? Why nowadays the people we are thinking on the traditional AI to generative AI? So traditional AI is limited creativity, 100% data dependence, and the traditional AI is more rigid. The traditional AI is more rigid. Okay, so these are all the various limitations of traditional AI. So to overcome that, we are going for the thing generative AI. So before we are going to move into the generative AI, some real world applications of rule-based AI, that is your traditional AI, expert systems for the field of medical diagnosis, financial analysis, and legal reasoning, then decision support systems, then game-based AI systems, and robotics. These are all the various real-world applications of rule-based AI. But even though the generative AI is evolving, but still some people are developing some game-based AI, some robotics, some decision support system. Always there is some value for the traditional AI. Okay, so that the topic is traditional AI versus generative AI. Some limitations are there, but depends on the application. We may develop some traditional AI also. Okay, fine. So now the feature before that. So you can just consider the integrating of rule-based AI with other approaches. So maybe combining the rule-based AI versus your supervised learning, that is machine learning technique. So combination of this both rule-based AI with supervised learning, which is the hybrid system. So you can just consider if you are combining or if you are integrating this, the synergy will be more. How we are saying is synergy is high is the rule-based system can provide the initial structural knowledge, while the machine learning can handle more complex patterns and adapt to the new data. So the power of rule-based as well as the machine learning can be integrated. That is also possible. So what is the feature of this rule-based AI is, so rule-based AI remains valuable in the domain where the transparency is needed, where the maintainability is needed, where the explainability is needed. So this rule-based AI is evolving in continuous. Then you can integrate with advanced machine learning, improved knowledge acquisition, and enhanced scalability. If you are integrating the rule-based AI, as I have already told in the previous slide, with machine learning, the knowledge acquisition and scalability can be getting increased. So the hybrid systems can play a crucial role in various applications that combines the best of the both supervised world as well as the rule-based AI. So this is actually the feature of rule-based AI, the combining with your machine learning or supervised learning. Okay, fine. So now we just due to some limitations of traditional AI, we are just raising the generative AI. So you can just consider in 2014, some GAN models can be emerged, that is generative adversarial networks can be emerged. And this particular GAN, which will show the lot of pathways for the image generation in your generative AI. Then in 2017, the various transformer models like GPT-3, which will demonstrate the remarkable text generation capabilities. So due to this particular transformer models, nowadays we are using the Chat GPT or Gemini, which is evolving much. And presently, the generative AI, not only in the image generation or in the text generation, the image generative AI is rapidly applying in the diverse fields, from even drug discovery, from the art processing, everywhere the people are using the generative AI. So this is actually the GAN architecture, which is a type of the neural network architecture comprised of two competing neural networks. In your GAN, there are two competing neural network architecture. One is called generator, another one is called discriminator. The goal of the GAN, the goal of the generative adversarial network is the generator architecture, which is aims to create a new data that resembles the training data, but the discriminator tries to distinguish between the real and generated data. So this is actually the concept of adversarial thing. Adversarial in the sense, maybe we are seeing in the next slide, what is actually this adversarial network. So here the generator neural network, which aims to create a new data that resembles the training data, while the discriminator tries to distinguish between the real and generated data. So now you can just consider this GAN architecture. So where there are two different networks, one is the generator, another one is the discriminator. As I have already told, the generator networks takes the random noise as the input, which will generate some synthetic data. Discriminator is going to distinguish between the real data and the generator data. So what happened is the generator will always tries to generate some more valuable data, that is better data. The discriminator always tries to distinguish between the real data and generated data. So competition between these two networks is very high in your GAN architecture. So quality of data generation will be more. The quality of data generation will be more. So this is, we have discussed how this data can be generated is, the noise generator starts with random noise as the input. Then the generator learns some mapping function to transform the noise into some realistic data, but which is not completely real, The generator will generate the data. Then the generator outputs the synthetic data that resembles the real data distribution, that resembles from the mapping function, it will generate some realistic data. So synthetic data, which is going to be resembles the real data distribution. This is actually the generator network. So now you can just consider the discriminator network. The discriminator always outputs the probability score, whether a data sample is a real one or fake one. So discriminator, what it will do is, you will be getting some synthetic data. So the data is going to be compared with the real data, whether it is real one or fake one. So which will outputs a probability score. Always for the good generative AI system, this discriminator probability score will be less. Then only your data will be more or less equivalent to your real data. So like that, you have two network in your GAN, generator network, as well as your discriminator network. So now you can just consider, this is actually the adversarial training process. So the generator always tries to fool the discriminator. The generator always tries to fool the discriminator by generating some realistic data, but the discriminator always tries to correctly classify the real and fake data. So what happened is, both the architecture are in the adversarial training process. Both architecture or both the network are in the process of adversarial. That means the generator tries to win the discriminator tries to win the generator. So what happened is, the data generation can be 100% realistic. Not 100% may not be possible. Maybe there is some errors are there. So the generator is trained to improve its ability to produce the realistic data. So the generator is always trying to produce the more realistic data. So you can just consider this is actually the objectives and loss function. So you can just consider the generator's objective, maximize the probability of the discriminator being fooled. So this is actually the objective of the generator. Then discriminator objective is maximize the probability of the correctly classifying the real and fake data. That means both the network, which is going to maximize its objective function, but the thing is, the generator is trying to fool the discriminator. The discriminator is trying to identify the data generated by the generator is fake. But anyway, the objective is both the neural network architecture, which is going to maximize the probability of the particular discriminator model as well as for the generator model. Okay, so this is the objectives and the loss functions. Some of the common GAN architecture: deep convolutional generative adversarial networks, and Wasserstein GAN model, then stale GAN model. So maybe you just see this various GAN architecture. Mainly this GAN architecture, the first one, the DC GAN, for the better image generation, The last one, the stale GAN model, which will generate the high quality images, the middle one, the WGAN uses the different loss function to improve the training stability. If you want to improve the training stability, the different loss function can be used this particular GAN model, then the training stability can be improved. Okay. So this is the various applications of GAN. That is the image generation, video generation, and then text to image synthesis. This is actually different applications of GAN. So you may just see creation of some realistic images includes a portrait, landscapes, or any artistic style images we can generate. And generating the realistic videos including animations or movie scenes or any news footages, even we can generate the video. Text to image synthesis, for example, like generating the image from the text description, like a cat wearing a hat. If you are giving the text, based on the text, the image can be given. So like that, there are different applications of a GAN model. So this generator and discriminator model is working in a feedback loop. So If there is a feedback loop, then only there is some harmony between generator and discriminator. So the generator learns from the discriminator's feedback, constantly improving its ability to generate the convincing data. So generator always learns from the discriminator's feedback. So that is very important. So we can get some convincing data in a periodical intervals from the generator, so that the harmony between the generator and discriminator is through the feedback loop, okay. So now you can just consider the image generation, or even some anomaly detection. Also we can use the application of GAN. The GAN, the generative adversarial network, can be used from the various image generation as well as some anomaly detection. What do you mean by anomaly? Is some unusual patterns. Some unusual pattern. You have some the same face images, through this particular GAN model. Some face is having some anomalies. So those anomalies can be detected by means of the generative adversarial networks. So identify some unusual patterns or anomalies in the data. So normally this particular anomaly, mainly the fraudulent detection. The Gen AI nowadays can help to detect fraud, even medical condition, diagnose medical condition, and the security can be improved. Okay. So nowadays the applications from image generation to anomaly detection, it is varying. The application of GAN, which is varying. This is actually the architectural consideration of designing effective GAN models. For designing effective GAN models, what are the architectural considerations we have to make? So the first one is the network architecture. So for modeling the GAN, choosing the right generator and right discriminator architecture is very crucial for better GAN performance. So this is very important thing, the network architecture, because the generator and discriminator is your neural network architecture. You have to choose the better architecture for this GAN performance, for the crucial GAN performance. Okay. And then for neural network means definitely some loss functions is playing a vital role. So for selecting the appropriate loss function, which is going to guide the learning process and ensure the GAN converges effectively. So the learning process can be guided properly through the appropriate loss function selection. That is very important. Then for any neural network, the regularization techniques like dropout or the batch normalization, if we are using these kinds of techniques, which may help for overfitting and which will improve the model generalization. Definitely there should not be any overfitting or underfitting in your CNN model. Whenever you are developing some CNN model, there should not be no overfitting and underfitting. So this overfitting or underfitting can be identified or can be avoided by means of regularization techniques like dropout or the batch normalization. So through this, the model generalization can be improved. What is the various metrics and benchmarks for the evaluation of GAN performance? You may just consider the inception score and two types of inception distance. So first one, inception score. This measures the diversity and quality of the generated data. So whatever the generated data from the generator model, what is the diversity and what is the quality? Some measure is needed. So that particular measure, which is called the inception score, and compares the distribution of the generated data to the real data distribution. The distance in the sense how the generated data is getting varied from the real data distribution. That is called the first one, the FID, the Fawcett inception distance, And the next one is kernel inception distance. This is actually more robust metric by comparing with the FID. So this particular metric, KID, which is focusing on some outliers also, but FID, which is not focusing on the outliers. Due to outliers, the distance can be varied, but whenever we are using the KID, that is kernel inception distance, the outliers can be considered. Based on the outlier consideration, this particular metric is more robust than FID. So this is actually we have discussed. So the key capabilities of the generative AI, so starts with text generation, image generation, the code generation, and the music generation. Even nowadays, some anomaly, there are n number of applications of this generative AI. So these advantages of generative AI by comparing with your traditional AI, the creativity can be enhanced. So more creative possibilities are possible by means of the generative AI, and efficiency can be increased. It automates tasks and accelerates the content creation. So efficiency can be increased and greater adaptability. It can learn and adapt to the changing environment. So adaptability also can be greater. So some apart from some conventional applications, by means of the generative AI, we can create some tailored contents for the individuals. And in drug discovery, accelerating the development of new medications, nowadays the generative AI can be used. And our virtual assistants, improving the capabilities of conversational AI, the generative AI can be used. And augmenting the artistic expression and design process, we may use the generative AI. So this conversational AI is playing a vital role. We can develop some kinds of our own personalized chatbots for our own purpose. We can develop. And whenever we are focusing on generative AI, some ethical consideration is very important. So first consideration, the generative AI models should be fair and unbiased. That is the first ethical consideration. Then misinformation and deep fakes cannot be considered. That is, we have to address the potential for the misuse and spread of false information. No false information can be spread out by means of this generative AI. And navigating the impact on employment and need for retraining. So job displacement, that is one of the important ethical consideration. And intellectual property, protecting the rights of creators, protecting the rights of creators and ensure the proper attribution. The IP, the intellectual property, is also one of the ethical consideration with generative AI. So before I'm going to discuss about the features of generative AI, hope so one of my scholar is joining here. We have developed one of the Gen AI model. So he is going to present that particular video of the case study. Hari Prasad?
Hello everyone. Sir, am I audible, sir?
Yes, yes, you are audible.
Sir, can you see me, sir?
Yes, yes, yes.
Yes. So a quick intro about me. I'm actually Hari Prasad and I'm currently pursuing my final year BTech Artificial Intelligence and Data Science in my college Dr. NGP Institute of Technology. I'm currently also an intern in a company, UST Global, and also about me, I have also published a study paper on the topic generative AI with my colleagues and my professor, my mentor, Dr. R. Karthikeyan sir, who is our HOD, and also my colleagues Satvik and Harish Khanna. And also we have participated in several hackathon and won gold prize on a hackathon which is conducted by startup team, which is called as Tirkathon for our project HAMS. So that's a quick intro about me. And yes, as Sar said, nowadays the AI is getting boom day by day. And last year we have seen the video of Will Smith was eating spaghetti, which was very poor performed by AI. But comparing to last year, within 6 months, within 6 months of period of time, we have seen the AI's growth in generating YouTube. I mean, in generating videos, we can see that on YouTube. The model which is called as Sora, which is developed by OpenAI, proves my statement and also SAS statement. So yes, I have created a project on generative AI. I have worked for it for 2 years and have developed a project. It's actually a group project. Our team developed it, and yes, which is called as Muller. Muller means it's not a girl's name. It's actually model for adaptive learning and automated response. So let me showcase you my project. So this is basically okay. Sir, it's saying like you can't share the content unless a host or co-host, the presenter, make you the
One
presenter.
second. We'll make the co-host. 1 second.
Okay, sir. Okay, sir. So this project is basically it's a personal assistant. It can do several things like it can generate images and also it can say the time, date, and also other works which can be done by the personal assistant. We have seen. I have inspired this from the movie which is Iron Man. In that Iron Man will be using a personal assistant called Jarvis, which will be doing certain work for it. So yes, basically Muller is also something like Jarvis. Let me show you the project itself. Yes, yes. Sir, see my screen, sir? Sir?
Yes, we can see.
Yeah, okay, sir. So let me show you the project. Yes, there are some queries to be asked for Muller. So let me show you how it runs. Sir, can you hear the sounds? Sir, can you hear the sound?
No, sound is not audible.
Oh, 1 minute, sir. 1 minute, sir. 1 minute, sir.
Starting Malar.
Sir, now,
yes,
sir?
Yes, is audible.
Okay, sir. Yes, starting.
Hello, Hari. Good night. The weather is moderate with a temperature of 21.8 degrees Celsius in Ward 8, Coimbatore.
Yes, it will be listening for the trigger word. Like I have said, some of the trigger words like "Hey Google," they will be setting like. So I have said "Hey Muller" as a trigger word. So whenever it hears the trigger word, it will be responding for my thing. Yeah,
Yes, Harry.
it's actually responding. Yes. What is the time?
The time is 20:55, Hari. Is there anything else?
Okay. What is the date?
The date is the 23rd of January, 2025. Hari, is there anything else?
Generate an image of a man flying in a space. Yes, it will be actually taking some time for generating images because it will be generating 3 images for a single prompt. So let me show you. Kindly wait for that. I can also do other jobs like opening the apps, which I have given the .exe files path, and other than that, it will be texting in WhatsApp. Like it will be opening WhatsApp and searching for the contact number which I have said, and it will be texting directly to them with the voice command itself. So let's see all those things. It's currently generating. It will be taking some time. And yeah.
Generating an image of a man
Yes,
flying into space.
the thing which is you are seeing on the screen is it had generated the images which I have told you already. So three images it have been generated. So you can see all these things. Yes, I was actually listening. Wait a minute.
Starting Malar.
Other than that, it can play songs on Spotify, and it can open YouTube and all those things. Let me show you.
Hello, Hari. Good night.
Oh my God, sorry.
Starting Malar.
So it is actually looking at the time and saying good night and good afternoon based on that. So I have set the code like that.
Hello, Hari. Good night.
And for the
weather is
weather, I
moderate with a
have
temperature
used
of
the
21.8
Open
degrees
Meteo
Celsius in
API.
Ward
That's
8,
how it's
Coimbatore.
generating the weather. What is there? Hey, Malar.
Yes, Harry.
Who are you? Oh, okay. Who are you and what are the things you can do? Okay. It's taking time. Yes, actually, I'm using the Zapier 7B beta for the text generation model, which is openly available on Hugging Face. So I have used the API for that purpose. So yes, it's generating. Sorry for the issue. It cannot able to fetch audio. I think there's a problem with that. But yeah, it has generated some of the text. You can see that. For audio, I have been using the 11 Labs API. 11
I'm
Labs
sorry
is
to hear that, but I need specific commands to execute tasks accurately.
okay.
If you could provide me with a
So
clear
for
and
audio, I
concise
have been
request,
using the
I
11
will do
Labs
my best to fulfill it in a
audio
timely and
feature,
efficient manner.
which is famous
Please let
in
me know how
audio
I can
API.
assist you today.
And for image generation, I have been using the Goofy AI model, which is actually a diffuser model. For the 3 images, I have been using 3 different Goofy AIs sub models. Okay, one is the 3D generation model, and another one is called as a Leonardo model, which is also a sub model for that. And another one is robotic model. It will be generating images such as robotic, which is filled with cyborg and things. So yes, that is what I'm using. And yes,
No
as I
problem.
said, for weather,
My
I have
user
been
mentioned
using
that they
the
have been using
weather
3
model.
different submodels referred to as diffuser
It's
models.
actually generating.
Would you please let me know which specific submodel should I focus on for these images? The user has not explicitly mentioned which submodel they prefer, so we could try all 3 and compare the results to determine which one produces the most satisfactory outcome for their
Hey, Malar.
specific requirements.
Hey, Malar.
Yes, Harry.
Open WhatsApp.
Opening
So it's
WhatsApp.
actually on the background, it's opening the WhatsApp. Message Amma that I reached home. Yes, I'm not doing anything. It's actually opening WhatsApp, and yes, it's actually searching for my mom's name. And yes, you
The
can
message
see
was successfully sent to Amma.
it was not sending right now. Sorry for that. Because WhatsApp was already open. Yes. It's actually getting everything as an input. Yes, basically it will be sending
I
my mom.
apologize for any
So the
inconvenience
last
caused by
text
the
you
user's
have been
reply.
seen was
Please
sent
provide
by
me with clear and
Malar,
concise
not by me.
instructions,
This I
and
have
I will
was
do
sent
my
by
best
my
to
mom.
execute them in a
I
timely
was
and
testing
efficient
it.
manner.
And other than
In
that,
case of unclear instructions, it may result in inaccurate or
Okay.
incomplete results. Thank you, and I apologize for any misunderstandings in the past. How may I assist you today?
okay, do you know about me? basically it's taking a lot of time because the API need to hit, right? So yes.
Malar. Sure, Harry. As far as I know, you are an outstanding student currently pursuing your final year of studies at Dr. NGP AICTE in Tamil Nadu. Apart from that, you are also a skilled SDE intern at UST Global. You have made some
Yeah.
phenomenal achievements, including delivering a study paper on generative
So these
AI
informations
and
it's
winning a
got
gold
by
medal
my
for your
previous
project, HAMS, at the
conversations. So it's
Thearkathon
generating
event.
actually with
Your
those
talent and diligence impress me, Hari,
conversations.
and I am always here to support and help you whenever you need me. Have a specific task in mind that you'd like me to perform for you right now? Remember, my abilities are extensive, and I will carry out any helpful task for you whenever you require it.
Okay.
Please enlighten me about your preferences, and I'll be there to serve you straight away. Here's looking forward to your command.
Play Lovely on Spotify. It's actually opening Spotify. Yes.
Love successfully played on Spotify.
Failed to enter, but actually it's searching and it will be playing. That's how it's supposed to be happen. Yeah. And that's it.
Vertical bar assistant, vertical bar.
Play Believer on YouTube. Yes.
Playing Play
It's
Believer on
actually
YouTube on YouTube.
on by its own. And yes, these are all the things which Muller can do right now. And also Muller can generate PPTs, but it will be really taking a lot of time because the image generation model need to hit the backend and it need to bring more images for the PPT. And also the text generation model also need to be worked. So for PPT generation also, PPT generation is basically a combination of slides module in Python plus these image generation models which I have already told about you, which is Goofy AI. And also for text generation it will be hitting the text generation model which is Zephyr 7B beta. So these are all the models I have combined to make the PPT. So yes, other than that, it will be it can set tasks, it can set timers and alarms and all those things. So yes, these are it can also fetch you the weather and also on all these things. So this is my project and I am looking forward to upgrade this into a real home automation in the future. And also if possible, I will be developing it as a like a real life robot also maybe in the future. So yes, that's all about my project.
Thank you,
Thanks
Hari.
for giving this opportunity. Yes, sir.
Thank you, Hari.
Thank you, sir. Thank you, sir.
So again, dear participants, so as we have already discussed, the traditional AI, which is having its own strength, generative AI, which is having its own strength. If we are combining both traditional AI and generative AI, our success of integration of AI system can be huge. So with this, the traditional AI versus generative AI, the comparison, as well as one of the Gen AI initiative, what we took through our scholar, that is a Muller. So we have introduced the Muller to you also. So with this, I am just closing my presentation. If anything to be discussed, you can even given in your chat box, we can have the discussion. Otherwise, I will share the PPT content to Dr. Sri Nagesh. He will share with you. Thank you. Thank you for this opportunity, Dr. Nagesh.
Thank you, Dr. Karthikeyan. Now I request Dr. T. Anuradha Madam to propose vote of thanks.
Okay,
this
sir.
session. So I request all the participants to switch on their videos. so that we will conclude this session.
Good evening, everyone. On behalf of all the participants, I take this opportunity to extend my heartfelt thanks to our esteemed resource person, Dr. R. Karthikeyan, for delivering such an enlightening and insightful session on traditional AI versus generative AI. Sir, your vast knowledge, clear explanations, and engaging presentations have given us deep insights into the fascinating evolution of artificial intelligence. From the foundation of traditional AI to the cutting edge advancement in generative AI. Your ability to simplify complex concepts, provide real world applications, and highlight the future potential of AI has been truly inspiring. The practical examples and thought provoking perspectives you shared have undoubtedly broadened our understanding. I would also like to thank you for potentially addressing our questions, which made this session highly interactive. Your expertise in the field and dedication to teaching and research are truly commendable. Finally, I thank all the participants and especially Hari Prashad for their active involvement. Okay, Mr. Hari Prashant, your research is truly impressive. The depth of your analysis and innovative approach you are taking are inspiring. Once again,
Thank you, ma'am. Thank you, ma'am.
once again, thank you, Dr. R. Karthikeyan, for
Thank
your
you.
valuable time and for sharing your wealth of knowledge with us. We hope to have the pleasure of welcoming you again in the future. Thank you, sir.
Thank you, ma'am. Thank you, Dr. Nagesh.
Thank you very much for nice and wonderful lecture. Thank you.
Thank you.
Before leaving, I request all the participants to fill the attendance sheet
Very.
so that attendance is compulsory. So I request all the participants to mark the attendance and then leave the session. So thank you, Dr. Karthikeyan, for a nice
Thank you,
and wonderful lecture.
thank you.
Thank you. Bye.
Thank you, Hari.